We are recording. It is November 11th. 2 times in a row getting the date correct.
It's not October 42nd.
Something like that. In a way, it would be. Go ahead and share.
It's 11/11 now. It's magical days.
All right, so I have it's a quick-ish one this week. So mostly just working on finishing and like continuously updating the literature review because it's been a first draft. So I guess at the end of the semester, then I have like the final draft once I get like a little bit of like revision and feedback from Dr. Crawford, who's gonna kind of I can go over those, see what's where to go from there. So I finished that on Monday and then working on the mask layer, just improving that because the first pass was like not the I guess ideal. But like the things were a little bit off. Get to that in a second. Working on loading the TIFF files to ArcGIS. I want to try using the ArcPy notebook rather than try to.
Come on in. Everybody, this is Karen.
Hello.
Hi, nice to meet you.
Let's do a quick introduction.
I'm Madison. I'm a master's student in my first semester, but I did my undergrad here. I'm working on like the indoor geography projects.
I'm Rebecca. I'm a senior undergrad in computer science, and I'm working on point clouds.
I'm Karan. I'm an undergrad student from here. I'm a computer science major.
Karen, you live in the CID building.
Mhm.
So he saw Tim Baird's presentation a couple of weeks ago and was interested in getting involved. So I moved to stop by. And Addison and Shashank are the two that are working on the project now.
Welcome.
I'm Shashank and I'm a second sem master student. I'm also doing the same thing as Addison, working on the CID.
I'm Lindsay. I'm a junior geography student, undergrad, and I'm a super term.
And Addison was just talking a little bit about the mask layer for the data.
So first off, I guess I'll go back to literature review really quickly. So for now, my topics are like kind of decided on. But again, this was just kind of like, oh, I need to have like this first draft decided on by a certain time period. So really just picking the research topics that I think I found to be like the most interesting and things that I could like find literature on. So the 2 main ones that I chose were how the indoor space can be used in like relation to clusters of material resources. So one way that I was thinking in terms of like methodology, going about processing that would be categorizing different areas in the CID building as like having those clusters, whether it's like access to see the TV, having like the better chairs or like having access to chairs, where the outlets are, if there's AC units, kind of seeing like, are you in a hotter area? Are you in a colder area? Kind of things like that. Next, just kind of how the indoor space.
You mean temperature wise, hotter and colder? That's an interesting idea.
That was
I hadn't
something
thought
that I was
about that.
thinking about, in terms of like, sometimes if the sun is coming in through the windows, because there's a lot of windows right there, it could get really hot in like one particular section.
Yeah.
I wasn't sure how we'd go about measuring that and then getting like a temperature thermometer type thing.
No, we've got a ton of cameras. We could start to like build like thermal maps of the place at different times of day and.
No, I would say the window sills in Goodman because there was a heating bed there in the winter and it was really warm.
Yeah, good idea.
Things like that can be kind of defined to material resources and then seeing like at certain times are those things used specifically for those resources, or is it just like you grab a table where there's a table, which would be a difficult thing to measure. But
I bet nobody's done temperature like this. Be interesting. We should talk to Tim Baird about that. Sorry, I know we've moved on, but we'll talk to Tim about that because he's going to get a chance to talk to the architects. And I wonder if this is something that they even ever consider. Like,
All of this is like really interesting for an architect.
I would think so.
Space influences everything. That's like their main like study.
Yeah.
in the literature, I remember there were a couple things where they were like relating building performance to like those kind of certain building or I guess like academic performance to like certain building qualities. But I don't remember if temperature was one of the things they actually looked at. So that would be interesting to kind of look into. But, yeah. And then the other one that I chose was just like how the endo space is used in terms of like resilience and disturbance. So basically disturbances are just like breaks. So whether it's like a weekend is like a very small disturbance versus Thanksgiving break and winter break being larger disturbances, seeing like, is it almost like a reset switch in terms of like, is the space used differently before the break than is after the break? Things like that.
That kind of makes me think of another thing. So Shashank, you showed last week the patterns of movement. I mean, it'd be interesting to see like if things settle into a more reliable pattern as the semester goes on. I don't know that we've ever thought about this yet either, but like, let's say, I don't know, what's our peak time? 4 p.m. ish,
Something like that.
something like that.
Mhm.
So we kind of do that. Well, what if like at the beginning of the semester it's super variable, but as the semester goes by, it starts like
It's more of a consistent.
dipping into this like reliable
Interesting,
pattern.
Yeah.
That'd be, I don't know how we're gonna exactly measure that, but I think it's measurable. We'll have to do some
maybe
thinking.
I have something about this. My presentation.
You do?
Yeah, I think.
Oh,
a
great.
little bit of this,
Oh.
Not like the whole semester, but the month of October.
Oh, good.
So let's see how like that looks.
So for the first draft, I have 22 sources and it's like 8.5 pages right now. Final draft should be about 10 to 12 pages. I have the source like amount requirement filled, but I'll probably still look to add more. Because there's a couple like sections that I wanted to get a little bit further into and then just didn't really have the time or like most of the time to think about it. It's one of those things that you have to spend some time thinking like outside of just the writing also. And trying to cram it all into like a week was made it difficult to do that. So creating the mask layer, we talked to Pingle about setting up the coordinate system properly. So the .tif files have a coordinate system. It's like an unknown coordinate system and it's not really referenced to anything, but it still technically exists from my understanding. But it would be, which I was like defining the mask layer as having that same unknown coordinate system, where we decided it would be better to like choose a pre-existing coordinate system, even if it's like not the same as the TIFF layers, basically just like having one that it can keep consistent, because having an unknown coordinate system is going to cause issues when you export things and bring things back in. So, and then setting like the coordinate system to a specific coordinate system, and then specifically setting the cell size and the snap raster to be the same as one of the TIFF files. Basically, that will make the mask layer, once you create the mask layer and make it into a raster, what it will do is it will ensure that you have the same dimensions, so the same amount of pixels, and then the cells are the same size. The cell size was something I found interesting. I don't know if it's exactly that number, because I was trying to go off of my memory when I was making this last night. And I had done this earlier in the week, but the cell size was something around like 0.5, 0.000000, and I think it was like 7.1 or 7.0. I thought it was interesting that there were
So yeah, so it's
10 decimal places.
so it's defined when it's created, right? We bin this, we create it, and we create it with a cell size of 0.5.
Mhm.
Is it 0.5 or 0.05?
It might be 0.05.
0.05, 5 centimeters.
0.05.
But yeah, I noticed that 7 tailing on at the end too. What I think is happening is this is a bit of an anomaly in terms of how computers store numbers. So you do get these weird oddball things that happen as a result of. Does that sound right, CS
Yeah.
people?
Mhm.
Yeah.
That can happen, especially if it's like the floats and. Yeah, very slight variations can happen like that. Like
Yeah.
sometimes zeros can be like, like 58 times e to the negative 25 or something like that, just because
And even if,
additions, conversions.
yeah, even if it's like a tiny bit off, it's not gonna, in the scheme of how many.
Right, and it's not
Pixels we
fixable,
have.
like it's
Yeah.
that is just the way it works.
You can always perform a concatenation or something and just like cut off the values past a certain like decimal point.
Right,
If you don't like the 7, it's causing
If
problems.
that's a consistent error, in that case, it could be a placeholder, which is important in the case.
It might be that as well.
Especially if there's any part of the code that's converting it from, like float to integer or back to float and stuff.
Yeah, and again, it doesn't really cause an issue, so I think it's okay to leave it.
it's okay to leave it, yeah,
But
don't worry about
I
that.
just thought it was interesting. So next I was trying to load TIFF files into ARC to create like an SCDF. So doing it in ARC was a little bit more challenging than I was thinking it was going to be. So first thing I tried was loading things directly using the add data button. Not a good idea if you're trying to do a full hour worth of data. So it will like attempt to build pyramids and calculate statistics for all of the rasters when you load them in like that. And I also will try to visualize all the rasters, which is not what you want when you're trying to add, 3,600 images. You don't necessarily want to visualize each one in your map layer. You just want to have them in the geodatabase so that you can process. So try to do that. It went for like 36 minutes and 30 seconds. I was timing it just to see like how long is it going to take to do this thing. And then it crashed ARC. And I don't know. I don't think it was really that far into doing that before it happened.
So as a reference, we were trying to figure out how long it takes compared to doing it in Python, just out of curiosity more than anything else. Shunk, you've been running all of the weekly aggregations. Do you remember how long it takes to do to make 1 hour's worth of a net CDF?
57 minutes, I think.
5 to 7 minutes. Okay.
So I tried doing it a different way the second time, which is using the ArcPy notebook to add them directly to the geodatabase instead of trying to have them build pyramids and visualize and do that. So it doesn't necessarily take as long to like get the file list and do everything. So
Neat.
doing this, the file list is like instantaneous. Like I name the source directory, list the TIFF files within there, print out the list, and then this right here shows up pretty much instantly. And then the second line of code for this is just trying to think of what this was actually doing. The in list. I think it was just converting like the data file into something that was a little bit easier to work with. But then when I try to actually add it to the geodatabase, it takes a very, very, very long time to do that. And maybe I'm not going about it in the most efficient method.
Does it have to be in a geodatabase to do the loading into an NetCDF?
I also don't know.
It's,
So,
I think like it needs to be in the same geodatabase, but you don't need to like do it in S3 notebook. You could like leave it overnight. It's not a problem.
You could what?
Do it in just normal like Python emulator or something.
yeah, and this is not something that's like my strongest suit, but yeah. I
Oh,
had
were
to
you
stop
doing it on your laptop?
Yeah,
Oh, well. Yeah, you may want to try that on one of the machines in here.
I'll give it a shot and see what happens. I'm thinking that ARC is probably not the best method in terms of that CDF file creation, but I'll keep giving it a.
Don't flail at it too long. It's
Yeah.
just a curiosity. We know that it was going to be worse. It's just a question of how much worse, and maybe the answer is a
It
lot
seems
worse,
like a fair bit.
way worse
Yeah.
than we want to.
And try on like a bigger computer. So it looks like it's using like all of your memory.
Yeah. It just seems like a fair chunk.
So the chance it can be faster with more memory, but no.
Probably try doing it on one of these.
Yeah, let's try one more time, and if it doesn't work, let's just stop.
And then CDF processing and analysis. Just working with Shashank for the final R programming project. So for the first project, we kind of just used the TIFF files and did like mean pixel values, things like that. This time we're gonna try to use NetCDF files instead, and develop it a little bit further, because we're hoping that ARC will be able to calculate mean pixel value and median pixel value and things like that for NetCDF files a lot quicker than it would for doing it for, you know, a couple thousand TIFF files. Doing it with all the TIFF files took a very long time for like the preliminary kind of analysis. Like it was like a minute or two to calculate some of like the median values and the mean values, and like do the addition and subtraction with the raster layers. That took a little bit, and that was only with 60 images. So doing it for a full hour would take probably a very long time. And I know you'll probably have a little bit more to add, or at least kind of doing some like the Python version stuff.
The other reason we are using NetCDF is because like we are using our own laptops to process this, and it's gonna take so much time. But if we use the ARC system, HPC system, we could like get fast results much faster. And transferring NetCDF to those is much easier than transferring like 3600 images.
No, more like, yeah, I mean, we've got one, so we end up with 24 files per day.
Mhm.
And I think it's 150,000 images per day is what it is if you do it that way. So you just lose all this time of like accessing file, transfer act, like it's way too long.
Yes.
So I remember chatting with a guy that ran the equivalent of like ARC at a different university. And we were also storing lots of things on lots of different files. And he's like, don't do that. That's way too much overhead.
So yeah, ideally we'll be able to see how Wednesday is more used during the day and Saturday is more used during the night, which would be pretty consistent with like those graphs that Sean made last week. And yeah, so that's kind of like my main goal for next week. It's like get pretty far into the NetCDF processing and visualization. And then also I'll be presenting on the literature. I guess the literature review that I conducted for my like geographic theory research class. And then also I want to work on cleaning and realigning the GeoSLAM August of 2022.
Sounds good, thanks. At some point, we'll have to decide whether we want to save all those individual files. Right now, we are, but we may want to not do that soon. It's. I'm not sure there's any reason to keep them.
The TIFFs.
If the NetCDF is good, we could get rid of the tips.
I think so. Maybe we'll just offload them and store them offline. I don't know. Anyway. All right, ready for Rebecca.
So this week, the first thing I did was try to see which, because right now we're using a frame of 0.9.2 to run the poetry loader, which is pretty outdated. I think it's like 2 years out of date, but sort of like what versions were farther than that, and the answer is none of them.
Yeah.
However, for different reasons.
Interesting.
So that's just gonna take some digging into to figure it out. So then what I did was decided to just go in a deep dive into the poetry loader to see how it works. And so I found some pretty interesting stuff. Basically, I already knew that the poetry is basically an octree. And so just needed to figure out how it stores that and how it implements it. So it's this little attribute called PCO, which is very useful. But a lot of you are probably asking, octree, what the heck is that? So basically, it's a data structure.
I was asking.
Yeah. We actually learned about quad trees in one of my classes, and I had to make a quad tree, and I like quad trees.
Oh.
They're really cool. So basically, it's a way of storing like region data in a way that you can have a lot of detail in one part and not a lot of detail in another part. So each point has to be in its own box. And so if you have lots of points in one area, you just have to make more boxes in that one specific part. And so if I were to add like a point G in here, we'd have to make even 4 more boxes. And the way that's actually represented in the computer is through a tree. With each node has 4 children and whatnot until you have the like data. And so basically to get that from 2D to 3D instead of 4 boxes, you have 8 cubes. That's octree. So this is how the point clouds are represented in poetry. And so to find it, you need to find this tree. So I did that. Finally,
Wow,
found the nodes.
wow,
It's very, very hidden and it's in this PCO, which I was not looking for. I was looking at data and like children and next data and objects, and it was not there. It's in the point cloud octree. And then you go to geometry and then you can find the nodes and the children. So the R is the root, and then it has 8 children, and then those children have 8 children, and then those children have 8 children, and eventually you'll find the points. But there's a lot of points, so there's a lot of children. So this is good. Since you can actually find the nodes.
yeah,
Find the points.
I want to get a look at this,
Yeah,
okay,
and so then, once you found the nodes, you need to find the attribute data. And so I think, oh no. There we go. It might be here. I found classification.
good
I was
job,
hoping for it to be like one number per node. I found it has 18,000 entries in this one array. And I
Huh.
think that this might be all of the classifications in one array. I'm still looking into what this buffer attribute does and how it works,
okay.
but at least it's here.
Yeah, this is great. This is the farthest we've gotten so far. Yeah,
Yeah. And so looking into it, yeah, there's 15,000 zeros in the classification, but then the color, because the line doesn't have any classification data, but it does have color data. And so it has 11,000 color data, and this one has numbers. And so now the task is to figure out what those numbers mean and how to use it. I think it might just be like RGB, RGB, RGB,
that's right,
but I'm
yep.
not sure for what and why.
3751 times 3.
That's probably
Seems
this
about
number,
right.
yeah, because this item is 3 and this item is 1. But like which one goes to which node? And these are things to figure out.
Yep, yeah,
However, this is a good first step.
this is a great first step.
Yeah,
Wow,
I've been trying to access it with like console log the classification for this point, and it like won't let me in. I can't find the PCO object, which is just really weird. But I'm working on it.
how did you figure it out? What tools did you use, or what were your ideas, like, how'd you get here?
I was looking through well, when I started last week was I was just like console.log the like poetry loader object and was just poking around in all of the attributes, because usually that's enough and it's like clear enough to find the data,
Mhm.
but there's just so many things. So I was looking into the code and and I found the PCO and the point cloud octree, and I was looking into it and I was like, oh, this is where the stuff is.
Would it, what would happen if you were working with a point cloud that was really small, like 10 points?
What do you mean, in what way?
Would it be, is it a small enough example that it would help you sort of pick through what's going on where? Because you could wrap your head around the whole cloud, so you'd be able to sort of
Maybe.
know where everything is.
Yeah, because you can at least draw it out. And
Okay.
this array might make more sense. So that might be something to
Let's,
just have like a 20-point octree or something.
yeah, let's do that.
Because this is like,
You get
I
lost.
started
in
going
it,
down a
yeah.
tree and it was
Yeah,
just like, it never ended.
Cool. Nice.
But this is something to work with. And this makes me think that what we're trying is possible.
That's great.
So I wasn't so sure before.
Yeah, it was getting dark sometimes.
Okay,
Um,
I'm done.
That's great. Good job. Chuck? Are we out of range? I'll move. I turned it off and on and that helped a little bit.
I tried that and. Supposed to be a light
Yeah, something
somewhere.
seems strange. Let's see, where, over here.
Does this take a battery or something?
Does, could be getting bad.
I feel like there's probably some sort of indicator that it has something on. I don't know about this one.
Can't remember how you open it.
Time for surgery.
Yeah, this. Okay.
So I showed some graphs last week, which were very interesting, and I did more stuff on those. The sad thing about that is like, is the mouse working now? That me.
It must be the battery then, because I'll let you go back.
I just went
I was
off
turning
track.
it off, yeah.
So the graphs I generated last week were pretty interesting, but the real thing was I didn't standardize them and they look like pattern wise, they look comparable, but as they were like different values. I didn't think like we could compare them based on that. And this week I did stuff on those, and the thing I missed out on was like I kept on overwriting my images, so I lost some of the graphs. So let's see. So this was the most interesting graph last week, and I think Addison told about that was a football game day, and players were probably going there. And I realized that this graph is particularly very exaggerated because the y-axis values are very small. If we compare, like, if we look at the graphs, like specifically in the way I showed them, we can see the Friday value are very peaky. But what I tried was I tried to make the y-axis values the same for everything, and then when I did this, so the blue line, if you can see it, this one, and this is the peak we are talking about. So it's not that big of a peak, but still, like there is a increase in activity,
Yep.
but it's not like what this graph shows. Like it's a very big peak, and I think like I also generated the same graphs with the same y-axis values, but I somehow overwrote them, and I couldn't find it yesterday. Maybe I have to generate it again. And because I'm using NetCDFs and converting into NumPy arrays, one day take like 10 to 15 minutes to work with. So it's like a little bit of time consuming thing. And that's why I'm looking at another way to do this. So when I saw this, the question I had was, what was the minimum, like when there's no movement, what is the activity level? That's what I was questioning myself with. And the blue line is like, if I remember, Tina said it, it's the fall break day. And that does have the least amount of activity. We can see that, but like there's a couple of questions I like had when I look at this. Suppose like around 3 a.m. I expected all the days to have minimal activity, but some days are like better or worse. I don't know if this makes sense, but I don't know. Like I'm still questioning if the mean pixel value is actually showing the amount of activity.
Yeah,
So,
I think it does, but it's very imprecise. It's noisy.
yeah.
Yeah.
And because of that noise, I like realized that comparing patterns were good, but like the question we had, like we could generate a marginal graph showing a pattern, but still there is some like amount for noise and stuff, I think. So the peak is like when I said there was a peak, how significant is this value? Is this showing something that's underestimating things or overestimating things? This was what I was still questioning, but still we can see like the thing Dr. Pinnell said, like there are some specific peaks. And this is the month of October, and during fall break, we see there is nothing at all. But there's still a small peak here, if you can see this. But like on regular Fridays, at this time around 9, there's very high amount of activity. And even here, there's high amount of activity. Like if I separate these graphs, this look like this. These two graphs are like pretty okay comparably. The weird thing is like on the fall break, which is expected, but the other one was 20th October. I don't know what happened this day. So keeping in mind that all of these y-axis values are the same, I think we can actually compare the peaks and pits now, but small fluctuations around 4 a.m. football game day, and then there's another one at 4-ish. So this is also the peak time we have like got so far. The weird thing is this graph. The weirdest thing was this, because I expected this to follow the same pattern of these two. It does around 9, but there's something happening again.
28th of October.
There's something not happening.
Do we have anything
It's
to
like, it
break?
should be like a,
Did something break?
I'm not sure.
Because one of the sensors have been,
But if that was it, there would be no
Down.
images, and if there was no images, there would be no values. There would be no net
yeah.
at all. We'd get like NaN values over here,
yes.
and I don't know.
And also, even if one of the sensors was down, it wouldn't affect the mean value.
I wonder if it's converting like null values to zeros or something in some part of the calculation.
If it's doing that.
Cause it feels like that shouldn't be like, there should be a base.
But I don't remember a day when we like found an error around 1 and then we fixed it around 3.
Yeah, we need to do a better job of logging what happens at these, you know, when a sensor goes down or we fix it or it comes back online. We started that spreadsheet, but we haven't been filling it in, so. Let's try to get back on that and figure out how we're gonna back calculate.
Could it be a power outage?
I don't think so,
Because there was a power outage in CID recently.
really?
Yeah, and then there could be like less light at that time, and that could have affected the sensor.
But does the LiDAR work with lighting?
It shouldn't, well. One could imagine that it could influence the intensity metric, I guess, a little bit, I suppose.
That's also something we should like look at, right? When we are comparing the graph.
Yeah, do you remember when the power outage was?
I'm not exactly sure.
I don't like the lights were out and everything,
Yeah, the power was gone for some time.
totally dark. Well, if that happened, wouldn't
Wouldn't the sensors not work?
the sensors not
Yeah.
work? Wouldn't the computers have shut down? Our computer's on a laptop, so
It's-
that one might have made it through the outage.
Yeah, it just wasn't being charged for like an hour.
Right.
It'd still be fine.
But the sensors would have turned off. We should have gotten an error message, right? It would have. We've got a tripwire in there that should have said like sensors not responding, something is weird, and it should have sent us a text. I don't remember if it did. Anyway, yeah, we'll have to look into that.
So because of the data in this state, like all of the other data like spans from 60 to 67-ish. But this goes way down to 52. And this is not letting us see the peaks in a way that could like. So that this is a particularly very specific day. I looked at other days as well, but those were not as bad. I only found this.
Is it just 2 hours? Is it 2 hours that it's down?
I think so, like it like 12 to 2.
So one of the things that can happen is if it bridges an hour, right? Like, let's say power is off from 1:30 to 2:30, then that's gonna have a signature on 2 different individual hour blocks. So that would speak to Karen's theory that it could be something like that, lasted an hour. Do you remember how long it lasted?
It
Or
wasn't an hour for sure.
do you know what time of day it was?
It was in the evening, then it wasn't for 2 hours. It was like 5 to 10 minutes max.
If the power goes out, we would not get a fine, right? Or would we? What would happen? Would we still get a net significance?
Some sensors are on PoE, right? So power over Ethernet powers some of them, right? So if the network architecture is on a switch that's like backed up on a generator, and I know that some of the stuff is, right? That's like high value networking equipment. It's probably on a battery backup. So if that's the case, some of our sensors would have still been getting power. How many sensors? 1, 2, 3, 4.
Oh, that
At
could be
least
some-
4 sensors would have been working.
That could be something behind this. If
Okay.
only we get like specific point cloud, you get to get the average would go down.
Yeah, so I guess the thing would be to like look at, and I think this is good advice, right? When you get these things, go back into the data and look at the animation and see what it looks like. Because you can pull it up and you can be like, oh yeah, half our sensors are out, and like we would know right away.
So how much of it is affected by like daylight?
I don't think it should be affected much, right? Like,
I don't think so either,
Because yeah, it's just like stuff that's causing like the difference.
but that might be an interesting analysis to run, right?
'Cause I
If
mean,
one
when does
sensor,
daylight be around 3-4 p.m.
yeah, I think we should look, right? Especially for intensity, but we might as well look for the other one too. And just track one sensor over the course of the day. Cause you'll see and get one that's like, you know, I don't know, I think we'll be able to see if the background. If you plotted it. Every single one, right, mean value, no. Minimum value, I don't know, we'll have to think about it, but I think that's a good idea, let's look and see what a sensor
The
does
thing about
in a day.
daylight is like, we talked about the things outside the mirror, where like things are getting reflected. That could be a region for like a higher mean. Because like midday, like when we look at the data
That's
set,
true, right, yeah,
there was some.
and so that would be a thing that would be fixable once we have the polygon, once we have the mask, right, we can chop out all the stuff.
It'd be interesting to look at like today's data, because today it's gonna be cloudy all day probably.
And we could do that to like a
And see
cloudy
if there's
day
any
and
like differences.
There was an outage on the 24th, but not the 28th.
Oh, how'd you find that out?
Can tell, I went on Twitter. On Virginia Tech Facilities Twitter.
That's awesome.
Well, the 24th, wasn't that the slusher outage?
Yeah, I don't know if it affected the CID either.
Is there a possibility that something might have reflected towards the sensor and then blocked the view for some time?
Blocked the view?
Like sometimes I'll sit with my laptop on the top floor and then the light just reflects off my laptop's like the mirror thingy and then just reflects to the ceiling. Something like that could happen to the sensor.
mirrors are like something that LiDAR does not deal with pretty well, but I don't know if that could cause like this much of fluctuation.
Yeah,
Well, if a person sits there for some time, like if there's an object that's just left over for like 2 hours, it could just reflect on the data.
And even-
Unless it's from multiple point sources, then it's not a problem. But if it's like a single sensor, then it could be a reason.
well, this would be an aggregate of 11 of them.
In that case, it's not a problem.
Also, I would expect an increase in activity rather than a decrease in the mean value. The only thing that experienced this is like, yeah, it got like 0 reflections.
Yeah, I would start going, and had a question about this. We've been backing everything up to the department NAS. It might be worthwhile to back up the animations, or at least one version of the animations to the Google Drive, because then we can pull them up whenever we need them, right? When it's on the NAS, they're kind of hard to access, but on the Google Drive, we just play them, right? Like as an animation, we don't need to download them or anything. So that might be a good practice, so that when we have these questions, they're easy to pull up. Cool, very good. So a couple mysteries to solve.
The things I am expecting in each of these graphs is like getting a value that's not lower than 60. That's like basically the average of every other graph I've plotted so far.
Always 60 is the low point.
Yeah, because like 59.5, that's not bad.
Yeah.
But if you look at this, it's like 52.5. So this is
That's way under. Yeah,
And I separated these graphs, looked at each, and they did not show like these kind of things.
Yeah.
The question, like I had this, like I'm not sure if this is like very clear, but if you look at this graph and this graph, we can see the same pattern. This is a Monday and this is maybe a Sunday. And this also led to me questioning the lighting conditions again.
And there's like the same kind of dip, like in the black line. As this one, but it's like less intense,
Yeah, that's right.
right
And
before 3 p.m.
And if the values do not correspond to the same thing, if 62.5 for one day is not the same for 62.5 for the other day, then like we are just looking at patterns, the numbers don't make sense.
the mask that you made is done, right? Ready to be used. All right, before we break today, let's take a look at that. Because we might as well be using that in your analysis, because that's going to cut off all of the reflection stuff, so that should clean up. Maybe not a ton of noise, but let's call it 5% of the noise, which is substantial. So if we can get that ironed out, that's all to the good.
And these graphs took a lot of time, so I was working on something else to address this. NetCDFs took like less time than doing individual images, but they also took like 10 to 15 minutes for like one particular thing, and it took like 1 hour or more to like look at a bunch of these. So I was working with ZAR files. So like when we started with NetCDFs, we separated 22 files, And I use the SIM22 to like make a ZAR file. This is something I talked about last week too. And what I did was, Dr. People showed me something like two ZAR method for a particular X-ray, but that did not work, and I proved it on last week. So the thing that was missing was to converting it into a data set and doing something like a mean is equals to m, which is basically like intensity in our case. But I just worked with this file and I was able to export it and then convert it into a ZAR file. I showed the structure of how ZAR was. We got a bunch of ones and zeros files. And this was like pretty okay. I was able to open the ZAR file, and the only difference I'm seeing in these two is like when you look at the data variables, like this is 255s and stuff, but this is turned into a task array, and it's referring something to the chunk thing. So I think the chunk is probably a parallel processing thing. That's the capability of task arrays, but this is not visible at all. And the other thing I ended up doing was converting the ZAR file back to the X array to do some analysis, and I got numbers, but I couldn't make any sense of these numbers
Okay.
because I got like
The 255 values, that's what we're using for nothing, right? So those are the not a number or whatever as an integer.
so this is just storing everything as a number in X array, while this is making a chunk thing. I think this is also similar to the tree structure you were talking about. Yeah, so this is what I got when I looked at the ZAR file. So it creates a bunch of folders, and inside those folders, I think this is the thing where everything is stored. And this is the tree structure for a ZAR file. I was able to look at these. I couldn't make much sense of it, but when you talk to people and I talk about it, we will figure something out. And I ran a bunch of things on ZAR. I got some things, but I didn't know what those were. And apparently, when I did the same thing I did last week again, I'm getting a new error. And the error is attribute error, nothing.
Okay,
So ZAR is giving me
that go back to that one. Yeah, it's not bad.
this was a very good thing. I thought like it would make so much easier because we could convert this into a number array like this a single method. But I couldn't even search for the error because there's like a blank error.
Well, that's just saying it doesn't have that function attached to it.
But this worked last week.
Yeah. Okay.
And I tried the same thing for 1 hour worth of data. I did the same thing, but for like 3588 files, and the same thing did not work. And this is like name ZAR is not defined. I thought I was not importing some libraries, but I'm not importing libraries. This is just saying like this is not available. I think like this is a function that says to ZAR. This is something I got, like I didn't type it out. I got it like using the Jupyter Notebook like tab, and it was there. So I don't know what I'm doing wrong. I even tried the encoding thing. Like I tried to use the encoding file signature for the ZAR file, but this does not work. I don't know what's going on with this. So
Oh, one note here, just by the way, this spatial graph is where we want to plug in. That's where like the coordinate system or projection information is going to go when we have it ready.
I think that's like pretty much easy using this. And the two data set thing, this lets you do a lot of things. Like this is something like this is only one of the many things I could do with the a variable, but I don't know. If this works, I was able to generate a few numbers. I forgot to do the screenshot. I thought this would keep running, but I don't know. So that was it. And I did like some literature review on Dask, but that's too much. I don't know what I'm working with. It talks a lot about chunks.
Right.
I'm not sure what that is. So that's it from my side. And this is the news I found.
I was going to talk about that too. That's exciting news.
And there was another news I didn't know whether to put it on or not. There was this, the owners of Oculus are designing a game that if you die in a game, you actually die.
I saw that was heavily advertised to me as well. I'm gonna slide on this, but I'll talk about it now. So Velodyne is kind of one of the older LiDAR makers. So they've been around for at least a decade. I think I bought my first LiDAR unit from them in 2012. And their LiDAR is kind of what's on a lot of the drone platforms. So like a couple of the drones that fly on campus that do LiDAR scanning, that's the thing that's on them. Ouster basically figured out what they were doing and then recreated it. So the Ouster scanners look almost exactly like the LiDAR, or look like exactly like the Velodyne scanners. But they have sort of leapfrogged them in terms of like capabilities. So they're faster and better and lighter and just like got much better. And so Velodyne, they've been sort of like diminishing as they go, but they also have a lot of contracts and they've got a lot of like business contacts because they were kind of the big company 5 or 6 years ago. So there's sort of like a lot of stuff going on there. So this is pretty exciting. This sort of like consolidates the field in a really useful way. We're hoping to get an Ouster scanner in February or so. Very good.
So goals next week, I am like still, we submitted the last project on R. And we are working on the final project on R, which will be working with NetCDF files. And I found like a couple of resources to use NetCDF files in R. So those been pretty good. We haven't started yet. And then I'll be working with SAR files next week and finishing my literature review by my proposal and it's still due.
Very good. Cool. Thank you. Benjamin will give you a chance to get settled here.
Oh.
I had forgotten to upload mine, so I'm going, I guess, next to last. Okay, so merger, that's exciting. While I was poking around on their site, I saw that they have a hemispherical LiDAR sensor, which is super cool. Let's just take a second and take a look at it because they've got I should have just captured the video here, but got a good page that sort of shows what you get. So a lot of LiDARs are forward facing. So the Velodynes aren't. So the Velodynes send beams out in sort of this like 360 degrees, but in these like stripes. And then the numbers that correspond with that are like Velodyne 16, Velodyne 32, Velodyne 64, and that's how many stripes there are. The Blickfeld units that we've been using are forward facing. So that's like, what's going on that way? And then these are super cool because they're hemispherical and they look like that. So you could put it on the ceiling and then you get the whole room, which is way better because what we've got to do now is like have 4 sensors in a room, right? Where you're like, what's going on there? What's going on there? What's going on there? And then fuse them together to get all the coverage. But if we could put this up at the top and do, have 5 of these instead of 12 of the others, like that would definitely be the way to do it. But these weren't out at the time, like progress marches on. Velodyne actually had one that for a little while, and I think that they must have been buggy because they had it and then they took it down, or maybe there wasn't enough interest. I don't know, but this is what I would like to do. Doesn't that look great? It's a neat data signature too. So one of the things when you work with LiDAR data is that the way that your instrument is designed and gathers data is going to affect the analysis that you can do with it because it's a different pattern of data coming in. But yeah, they've got a couple of other examples. Pretty sweet. Anyway, yeah, that's a neat one. Okay. So probably nothing that we're going to, the disadvantage here is that, we're still hoping to use Percept, which we got an email from them that says they've got a new version of the Percept software, which is supposed to be sort of the object tracking for the LiDAR that we've been doing in CID. So if that works, I need to get that installed and try it out. I don't think that's on my lab report. Virginia Tech is one of the only places that has been tapped by the FAA to do certain kinds of testing for drones. One of the big limitations for drones is that you can't fly over people without a waiver. So you have to get permission from the FAA. And they've been, the reason for that is we don't want to crash into people. But a year or two ago, they started to open the door for like, well, we're going to authorize flying over people without a waiver as long as it has passed this fairly rigorous like safety check, right? That it has some safeguards for flying. So this is the first one that's been approved. I'm not sure even if it's been approved, but it's been tested and it's been authorized for approval. It's a fixed wing drone. This is an EB. And the great thing about these fixed wings is they can fly for a long time. They're super efficient. So a lot of times we fly quads. In this lab, we only fly quads. Quads are really maneuverable and they're up and down, but they're also a lot less efficient. So the lift that you generate by going forward is just much cheaper. So I'm super interested. I don't know, if this can fly over people, then this would let us do something like scan campus in a really effective way, right? Where we don't have to worry about crossing over roads and people, and we don't have to, because right now it would be impossible. You'd have to set up 1,000 observers and you'd have to make sure that the place was clear, and you'd still never be sure that like you weren't flying over some random person that was going over. So anyway, this is really good news. Maybe within a couple of years we'll have drones that we can fly in urban areas. Right now, because of the restrictions, these are mostly useful for agriculture or forestry monitoring, things like that. So neat stuff. This is Luma AI, a new LiDAR scanner for the iPad. So iPads and iPhones can have LiDAR on them, depending on which version you buy. We've got an iPad with a LiDAR scanner. Last year, we spent some time looking at a bunch of the different scanners. They're okay. I think that they haven't been sort of utilized to their full potential. This one caught my eye because it uses NeRFs as its basis for the calculations instead of other things. So I haven't tried this out yet, but this is kind of a note. If somebody wants to try it out, then let me know, and happy to let them do that. All right, Gunjan and I were at AutoCarto, so a lot of things were there that were pretty neat. This was one. So Yulan gave a presentation on, they were looking at COVID, but they had a space-time visualization that I was interested in. And they ended up using this D3 package. So D3 is an old JavaScript way of showing data on the web. Mike Bostock is behind that. He has developed Observable, which is sort of a new incarnation of D3. So she was using these together. This is an example of that being used to track whatever. But it seemed like something we might be able to tap into if we're trying to share some visualizations of the LiDAR data in CID. Maybe this is a way that we can do that. They were also using, she was also using Plotly, which I hadn't seen before, but this would be for sort of making something that's a little bit more interactive on the web using Python. It's probably a little further afield than what we want to do, but it was an interesting thing to make a note of. Brendan and I were chatting a while back about making a plot for his thesis work. I think we couldn't remember the right name for this. So apparently parallel coordinate plot is
The bump plots.
yeah,
Oh.
but I think parallel coordinate plot is the most common name for this. Somebody was using this and I was like, yeah, that's what it was. So within our universe, this is the most common name, parallel coordinates chart. And I think we still should have as like a summary thing, right? Not redoing any of the things you've done, but like and this is how we think it worked out in the end. I met David Padgett, who is a panelist at AutoCarto. He's at Tennessee State. He had some really neat ideas about participatory GIS, ways to talk to people and get input from the community and sort of get that sort of community knowledge into a GIS, which is often not well done. So this was good. That was interesting. Just the idea of sort of taking people. So like one of the things that one of the projects that I'm working on is one with Theo Lim. They're trying to get community engagement for developing strategies to mitigate like urban heat, right? And one of the things that they're interested in is like adding more trees to these neighborhoods. And there's a lot of reasons why some of these neighborhoods don't have as many trees as would be optimal for temperature. But they wanted to sort of like get people to provide input about where would you like a tree? And he's like, go for a walk, right? Which is sometimes not the first thing that comes to mind when you're doing a lot of GIS work. But just go for a walk and like don't worry about like how you're going to encode things, right? Just like get the information and then worry about how you're going to digitize it later. I also thought that maybe a follow-up session in Google Earth in VR would help ID important things. So I did get the VR headset working with Google Earth. If you guys have some time after the meeting and want to try out Google Earth in VR, it's quite a cool experience. So maybe you can see what I mean. There's a lot of really good stuff in there, and I think it could be a good way to do it. I can't even sort of remember why I had grabbed this. David Padgett had talked about this, but maybe I thought it was going to be useful for Theo. But it's a mapping tool from the EPA. We're often interested in sensor data, right? So he was talking a little bit about Purple Air, which manufactures some sensors that are, put their data up on the cloud. Maybe this would be something of use to Theo.
Those are pretty cheap. What? Do you know what exactly it tracks?
I don't know. I would guess temperature and humidity, and usually it's they track particulate matter at different sizes.
Okay.
Yeah. I've got one actually that I bought. It's super sweet. I'll bring it in. It doesn't publish its data anywhere, but it must be built off of like a Raspberry Pi or something like this. It's got a little screen. I bought it for like $50 on Amazon, and it just gives you a readout of the particulate matter and the temperature and humidity. It's a neat little piece of equipment. And the only thing that it doesn't do is like publish its results, but I'm sure that would be a minor thing to add, like add it on Wi-Fi and like spit those out to somewhere.
In one of my remote sensing, or I guess my remote sensing course, we have like research projects. My research project for that course is focusing on air pollution and like satellite data measures, which are, from what I've gathered so far, pretty not great. They're good for like large area, but for a small scale, you can't really do much with them. But I'd read an article that like the ones that are being used by like the government, things like that. And I guess these are probably the ones that are specifically for SO2 and O2 and things like that are like $100,000.
Oh, wow.
Yeah. But I guess they're like full on powered stations that like probably track it at a very fine.
Yeah, there's this interesting trade-off between like something that's really reliable and works all the time versus like, what if we just like put 1,000 of these out into the city? Just give them out, right? Like just put them up at your house. Like, let's gather the data and just see what happens. Like, would that be better than spending? Because what is this like? Let's call it 300. Like you're the government, you could get a discount if you're going to get 1,000. So let's call it $200 each. 10 is 2,000. 100 is 20,000. 1,000 is 200,000. So that's a pretty small price tag for 1,000 sensors distributed in your city, I would think.
Yeah.
Neat.
This is interesting.
This is another neat one. I didn't have a chance to sort of spend a lot of time on this. Somebody was using this to map. Can't remember what. But this is a developing species distribution maps and species distribution. Actually, I was talking about this on analysis, right? You have observations of where you saw things, but you don't really know. Like if you don't see a thing, is that's because you didn't see it or because there isn't one there? And it's often really difficult to do a comprehensive species survey, right? Like think of what it would take to like definitively sample lots of animal species that are hard to spot. Plants are pretty easy, right? You can go and you like count if you can, but like animals are really hard. So you depend on these sort of like scattered measurements. So this was an attempt to maximally use those scattered measurements in a way that was robust and would work, because it's basically rests on geostatistics, and not everybody has enough geostats knowledge to do this right. So if you can kind of embed that into a package, it might work. So I wondered if we could use it as part of the build project. I'm not sure that it tracks, but yeah, I can't remember the presentation that I saw where they were using it. They weren't using it for species distribution. They had sort of bootstrapped it into another thing that they were trying to figure out. I guess I'll have to think about that. It's a big conference. Bernard Yenny was there at the conference. This is a link to the talk that he gave at NASIS, which is the cartography conference a couple of weeks earlier. And what he was trying to do was enhance these. This is sort of a machine learning based way to create hillshades in a way that's way better than a standard GIS can do. So standard GIS has like a hillshade tool. You run your data, it looks okay. But the difference between that and sort of what you can do if you really know what you're doing is huge. And so he was trying to write software that sort of like can mimic what like the best people can do. So it's like a deep learning input effectively, right? Like he's got all of these maps of like what the Swiss cartographers did. That's like, these are perfect, like handmade stuff, like super a lot of effort put into it. He's like, well, we know what the DEM inputs were for those. We know how they turn out. Can we just like get an AI to copy that technique? And it turns out you can. And he's got some dials that sort of do this. But I was particularly interested in this flat areas details thing that he did. The maps that we have up there, like the 3D printed maps. I've got one for the United States that we put together. It's a puzzle. And there's some really great features that are sort of in the low-lying areas. But the mountains look terrible. And so we've been sort of looking at ways to sort of like make the mountains look better, but without erasing all of that detail on this stuff. And I've got a way of doing it that I'm hoping to publish, but it sounds like Bernie has another way of doing it. So we chatted a little bit about that. At the place where I got my PhD is UC Santa Barbara. The new department chair there is Trisela Nelson. She does a lot of work on biking. And so one of her graduate students, I think, put this together. This is maps.org. It uses OpenStreetMap data, but they're trying to track usage and accidents and all kinds of other neat things. They had some really good information about best practices for bike lane tagging. One of the things that I always find shocking is like how poor the bike maps are for places. I'm not totally loving this as like the cartography, but the data underlying it is probably pretty good. So in analysis, for instance, I may have, like, we'll probably do an OpenStreetMap unit, and I may have you guys like try to follow these best practices to like tag the bike lanes or whatever in Blacksburg, if they're not well tagged already, which they might not be. Okay. Build project. So Addison has been working on the Polygon stuff. This is a little old at this point, but I was gone last week. And so this is just to document one way to get everything to match up, because ARC doesn't always like to work if it doesn't have geospatial coordinates, right? It's kind of made to operate using Earth data. And so our data is spatial, but it's not geographic, let's put it that way, right? Like we know where it is and it's got meters and it's got everything, but it's not like located on the Earth's surface. So sometimes ARC can struggle with that a little bit, depending on what you're trying to do. So this is one way that he's already talked about to make it work. And then you're going to do this as well. But I was trying to find out if we could get the new GeoSlam scan aligned with the old one. So last year when the project got started, Todd lent me the GeoSlam unit that he has, and I got to learn a little bit about how it works. And I took a walk through CID as it was construction was just finishing up. And then in August of this past year, a couple of his students came in to do another scan. So we have two scans of CID done with the than with a portable LiDAR scanner. The new one is a lot better than the old one, plus it has all kinds of furniture and neat stuff in it, so it looks a little bit better than this one has like ladders and stuff, and there's nothing in it. So I was trying to align the new one with the old one. So that worked fine. The new scan has about 15 million points, which is a lot better than the other one. And so you can see we've got tables and chairs and stuff. Now this furniture moves around. So that's an issue. But it, you know, it's pretty good. It's pretty good reference scan. And then I also was playing around with ZAR. This is just opening up a NetCDF data set that we already have, and then using the 2ZAR to spit it back out again. I was just interested in conversion time. It took about 2 minutes per file just to do the conversion from one format to another. So that seems pretty reasonable. We've got 24 per day times how many days of observations are we on now? Are we getting close to 90? So, you know, it adds up, but it's still within our capabilities to do these. I can't remember, one of the things that we run into is sometimes these have significant memory footprints. They're, you know, can parallelize this out a little bit, but sometimes it's still kind of costly. And then Beth Pryor had contacted me. She's trying to get some LiDAR data from their helicopter from Strubles Creek published. She spent a lot of time on that, especially last summer, I think. But one of the things that she found is that when she uses Cloud Compare to do some of the alignments that she needs to do, by the time she spits it back out again, the projection information has been erased. So it becomes a little like our CID data, right? There's coordinates, the space means things, but it's not like located on the Earth's surface anymore. And in fact, it is, it's just, it doesn't know where. So this was a surprisingly annoying problem to deal with. PDAL can't read the Cloud Compare output and gives an error, this like runtime error. I had fixed that at some point and couldn't figure out how to fix it again. And apparently I didn't document it in my lab report. So we're a little bit, that's bad. In ArcPro, you can define projections, which we do like in classes or whatever. That works fine. You can define a projection on a LiDAR file, but it just sticks this like .prj file next to it, which is not what we want. We want to embed that data in the LAS file itself. You can define projections using LAS tools, but you can't define both the horizontal datum and the vertical datum for some reason. So a horizontal datum means like, what's your 0 point, right? And you might think that that would be well established, but in fact it's not. It has changed over time, and so there are hundreds of horizontal datums that you could use. There's only a couple that are really common, but those two are different. So you've got to tag that in there. In the United States, we use North American datum of 1983, the 2011 revision. And these are things that matter when you're trying to get things located to within like centimeters or millimeters, right? Like this is the level of precision that we're trying to get to. So that's what we use. That is itself going to get updated. I think next year there's a whole new one that's coming out. So everything's going to have to be re-referenced. But so far that's kind of the standard. And then this one is a vertical datum of like, okay, what altitude are you at? And in some ways that's the harder of the two. So we use one of those called the North American Vertical Datum of 1988. And each of those has these unique codes called EPSG codes, but you can only assign one of those at a time. So you do that, you get it's partly referenced and partly not referenced. It's fine enough for what we do, but she's trying to publish this to Open Topography, which is like the Wikipedia of LiDAR data. And so that doesn't work. You can also use OGC strings, which could have both. You can add the stuff in there, you can verify that it's correct, but when you go to load it in ARC, you still get this unknown coordinate system, even though it's definitely embedded in the thing. So this is like ARC, not it's ultimately a standardization problem. Like this metadata is supposed to be in here. People aren't really doing it right. There's like 5 different groups that are doing it, and they're, you know, if you do it in their system, then it works from their system, but it doesn't work if you get it in this other system. So I was like, all right, how do we do this? So I did it 2 ways. The first thing that I did was I tagged the datums in here with LAS tools. So I'm removing the variable length records and the extended variable length records. I'm adding in the 2 datums that I need. And in fact, I think I'm doing it twice. So this way and that way. I'm just sort of like throwing the kitchen sink at it here, and like some of the stuff has to work. It still doesn't totally work. Like you can verify that information is in there, but when you go to load it in Arc is like, I'm not sure what you mean. So I do a second pass with PDAL after I've done this. And then here in PDAL, you can specify both of these datums. So this is the horizontal datum and this is the vertical datum. You have a sign in there that says that I'm using 2. And then between the 2 of these, that works. Everything's in there. I load it into Arc, a separate program, and then that is convinced that all of the stuff is in there and I don't get that error. So it's a tricky problem. It took me about an hour to figure it all out. And so it's not like, I still think this could be a little bit better. Probably I'm doing more here than I need to do, and I could probably refine this, but at least this gets us in a place where we can do things, even if it's not the best way. And then I reran Opus. So the RTK GPS correction station that I have on the roof of my house that provides corrections to us when we go out and like try to take survey points, again, to get things accurate within a centimeter or 2. That's what this is for. I wanted to rerun that to see how things were going. I presented on that last time. These were the results that I got. So I ran it through Emlid Studio using, there's a correction station at the Blacksburg Airport. So when you do that, you get a latitude and longitude of this. So the question here is, what are the coordinates of the thing that are on my roof, right? Down to within like ideally sub-centimeter precision. So this is what you get when you run it through the Emlid Studio stuff. Don't worry about the latitude and longitude because it's hard to interpret what these big decimals mean. But if you just focus on the vertical components, this is 640 meters above whatever. So this is 640,509. If you run it through Opus, which is the National Geodetic Survey's way of doing it, you can just basically take your log file and upload it to them, and they'll be like, here's where that thing is. That will tell you that you are at 640.455. So you can see that we've got a 6 centimeter difference between these 2 methods of figuring out where we are. Ideally, I would have liked to see that agreement to within a couple of centimeters. So it's a 6. It's more than I would like, but not too bad. And then you can see that these are essentially using 2 different datums. So here you can see that the datum that you're using can put you off by, in this case, over a meter, right? So you do get these big differences when you're using the wrong datum. So when you start to get to the point where you've got to be accurate to within a meter, you have to know what you're doing with respect to the datums, make sure you're keeping those correctly. Otherwise, this is pretty good. This is the raw mean that I calculated last time. You'll see that this is different than just about everything. I would have expected this to maybe line up with this. It doesn't, but I also discovered that it was receiving its own corrections. And I'm not sure why that happened. So I'll have to figure out if that affected the calculations. But anyway, some progress there. My goals in the near term are to figure out what my goals are for the next few months, month and a half. I need to submit Colleen's paper. That thing's almost ready to go. It's just a matter of sort of formatting references and stuff like that. So hopefully not more than 6 hours of work to get that out the door. I'm going to get Gunjan's paper submitted by the end of the year. I'd love it if they would give us a month extension on that. That would make such a big difference in terms of getting it out. And we could ask if it comes to that. I'm sure a month won't matter either way. And then I want to start doing some drone flights a little bit more regularly. Once a week would be nice. Now that I'm off crutches, so now I'm a little bit more mobile again, feel a little bit more comfortable. I was always worried about, well, if something happens and I've got to like go get a drone that's crashed somewhere, like I don't want to be on crutches while I'm doing that. So I've been not flying. All right, that's it for me, and then I guess it's Benjamin's turn.
Doing pretty well on time. It's 11:18.
Do have like a very short presentation. Take this time. It's- Okay, so the first update is like I presented in the conference, and it was a great experience because like we like met like lots of people from academia, and it always feels good like there are like lots of people talking about ideas and like also like people working in the industry, what they're actually doing, and like whether like what I'm doing, whether that's relevant or not. So it's kind of like a validation of like, okay, people are liking it and it's kind of like relevant. And also like talked with some professors as well, like Dr. Pingle told about I forgot his name, professor from Tennessee State.
Oh, David Paget?
Yeah, David Paget, and his colleague was there, Dr. Reginald Archer. So he also had this kind of idea. So I was talking with him, and he attended 2 presentations. So some of his project ideas match with that, and some of them match with mine. So it feels good. Like, so my research is relevant, and it could be helpful for some people. So yeah, and I guess like I did like kind of like a survey, like I was talking with students, and I guess I was the only master's student there because the rest of them were like PhD candidates, not
Yeah.
even, like PhD first year, second year.
Yeah.
So that felt kind of like good. Yeah, it was a great experience overall. I learned a lot of things, and yeah, here's Dr. Pingle on the opening ceremony. So yeah, it was good experience, and had some difficulty coming back to Blacksburg during the flight delay and everything, but at least I'm in Blacksburg, so that works. And the other thing is like I'm working on the methodology section, and I have to like start working on the journal manuscript because the way I'm writing it's more in a thesis format, so I need to like tone it down for the journal. So, and the deadline is December 31st. And again, as Dr. Pingle mentioned, it won't hard to get a month extension because I'm planning to leave US to visit my parents on like December 9th. So yeah, so yeah, like during that time, like working, and because of the time zone differences and everything,
Right.
because this time it's like, I don't know, it's like 10 p.m. in Bangladesh. So yeah, it will be kind of like difficult to like work out the time zone as well.
Yeah.
So yeah, but still I'll try my best to do as much work before I leave. So yeah, that's it. And other thing in that I didn't mention here is like, so I'm still not decided because like I have my results and everything. And if the defense was due in December, I guess I could have like pushed to that as well. But as I'm starting my PhD, like planning to start my PhD in fall, so there's this a semester kind of thing that I have to work out. So I'm applying for jobs. I attended 3 interviews this week. So it's taking a lot of time figuring that out and like considering the visa complications and everything. So it's getting a little bit difficult because maybe the job is good, but it's not aligning with my requirements with the visa thing. So still trying to work that out. So yeah, that's how it's going. So yeah, and the goals are like keep working on my both dissertation and the journal writing, and hopefully like I'll be here for the next semester as well. Like in maybe the form might be different. I'm still figuring that out, but I'll be here and also like keep attending the job interviews and confirm one for the spring. So that's it for my presentation.
That's great. Yeah, thanks, Kunjan. All right, well, with that, we can wrap everything up. Go ahead and shut the Zoom session down. What were the couple of things we wanted to do before we left today?
We are in the mask.
The mask, we were gonna make sure that it's